All right. I think let's go ahead and get started. Folks are continuing to trickle in, but welcome everybody. We appreciate you joining our webinar today. We'll be talking about operational and embodied carbon, uh, covering a number of topics. But first, to introduce ourselves, I'm Patrick. Many of you know me from other Ekotrope webinars. I'm customer success account manager for HERS raters and providers. We're also joined today from Jacob Rakusin, who's with Builders for Climate Action. I don't know if you want to add anything, Jacob, but
Yeah, I head up a lot of our research work at BFCA, focused pretty heavily around embodied carbon, climate impact reduction in general, really focused on the residential sector, and I'm behind the redevelopment of the BEAM tool, which we'll be talking a little bit about over the course of the day.
yeah, absolutely. So to give some high level, what are we going to cover today? We're going to talk about how operational embodied carbon emissions work together, how HERS raters play a role in that. We're going to start kind of high level, just what is embodied carbon. We're then going to talk about the RESNET 1550 standard, which was released earlier this year. And then we're going to go even more narrow and talk about a 100 homes study in Massachusetts that was done where 100 homes received a HERS rating as well as an embodied carbon assessment. The standard didn't exist yet when the study was being run, but it follows a lot of the same methodology that wound up in the 1550 standard. So from there, we'll talk about some of the results. We'll talk about what happens when you look at the operational emissions and the embodied emissions. We'll also talk about the HERS rater experience of doing embodied and operational HERS rating, and then talk about what's next. So we do have a Q&A section. Feel free to ask any questions. We'll be answering some along the way, but there will be time at the end of the session. This session, we do expect to run a little bit longer than uh, an hour. We should finish up the slides in about an hour, but then there will be time for questions at the end. So with that, I think I'm going to hand it over to Jacob to kick us off and talk through some embodied carbon.
Excellent. Thanks, Patrick. So just want to start with some basic definitions of terms and level setting for some shared understanding of what we mean when we say embodied carbon. I know it's a new term and a new field of study for a lot of us in the industry. And before I get into the details in the slide, I do want to acknowledge that you're going to see some diversity of metrics here going between imperial and metric system units. And part of that is because in the world of embodied carbon measurement, the conventions really are around metric units. It's kind of an international field of study, so it's very typical to see metric emissions. But here in the US, obviously we use imperial units a lot, especially for areas and so on and so forth. So just want to acknowledge the swapping of different units here between imperial and metric system, and we'll try to kind of call that out and make that as clear as possible, given the context of some of the studies that some of this slide content is coming from. So having said that, looking at like just a general sense of scale, and we're going to define terms of what embodied carbon is and boundaries and all of that in just a moment. But generally, we know embodied carbon is these emissions that are released from the process of construction, not directly related to energy use. We'll define that more accurately in a moment. But how big of a deal is this? Is probably like one of the number one questions we hear. And particularly, why do we care about that in the residential space? Often when you hear about this, we think about high-rise construction or, large amounts of steel or whatnot. If we look at the average emissions for a given single-family residence and multiply that out by the annual new home construction, floor area construction over the course of a given year, I think these metrics are from 2021. We see the emissions just from the materials it takes to develop that amount of new construction is equivalent to the emissions of the entire economies of, say, the countries of Austria or hungry. So we're really looking at very, very substantial amounts of emission that are released, just dispersed across a whole lot of construction, as opposed to a small amount of large buildings. We're talking about a huge amount of small buildings that adds up to a really, really significant plume of emissions. So just a bit of a scale reference there. The other relevant piece around embodied carbon that's different from operational carbon, again, operational carbon being the carbon emitted from the energy associated with the building's use, embodied carbon essentially being colloquially everything else, and we'll define that a little more accurately in a moment. We really see, if we're looking just at the emissions associated with the products going into buildings, that's where the lion's share of the embodied carbon emissions occur, and all of that happens up front, meaning it happens before the building is even occupied. So looking here after the first year of occupation of a building, over 55 metric tons of emissions were released just to bring that building into creation. That's really, again, just looking at what it took to create those products, relative to about 3 tons of emissions for that average building over the first year of its operation related to energy use. And so if you look at that over time, we see we're essentially front loading 15 to 20 years worth of operational emissions prior to the building even being occupied. So when we're trying to make reduction goals within, say, a 2030 or a 2040 or a 2050 time window, whether that's because we're mission driven around our emission reduction, or whether we're trying to comply with a program that calls for reductions within a window of time, the timing of that release makes a really big difference. And so understanding that there is that sort of front loading of embodied emissions that happens before occupation is a really important concept in terms of how we choose to prioritize or where it's worth sort of leaning in to reduce some of those emissions.
Yeah, and Jacob, just one thing to add there is I think, this is almost good news in a lot of ways that, you look at the average HERS score. Last year, I think it was about 56 or so. Uh, that means we've removed 44% of operational energy compared to a home built 20 years ago.
Mhm.
So 20 years ago, the payback period was a lot, the 3.1 number there was, 44% larger. I'm kind of mixing some math here, but the reason embodied carbon is such a big deal now is because we've done such a good job of making homes more efficient. So that's kind of why, hey, maybe there's diminishing returns on some of the uh, energy efficiency metrics, but there's this whole other uh, area of emissions that we aren't really looking at currently.
It's a great point. And I'd say the optimist in me would say the glass half full perspective is we have so much opportunity in the embodied carbon space of bringing that 55-ton number down the same way, Patrick, to your point, that those opportunities have been realized on the operational side after a couple of decades of really good, hard kind of industry-led work. So let's sort of start to put this into the context of the standard. I'll keep giving some additional definitions here as we start talking about the standard. Part of the reason we needed the 1550 standard, this is a standard that was initially developed through the RESNET organization as a RESNET standard, and is now in the process of turning into an ANSI standard for broader adoption and adaptation in other environments. The part of the point here is, I guess, riffing off some of the same discussion from this last slide of looking at operational versus embodied. In the operational space, there's a lot of complexity around, how to, like, what to measure within a building, all the different sources of energy use. And some of them are really dynamic, like variable speed compressors from a heat pump or what have you. And it could be, or owner influence controls. There's a lot that can make the measurement of energy complex, but the boundaries around what we're measuring super clear. It is in the building, the energy used inside the building during its use phase. That is very consistent and totally clear. And so the standards tend to really focus on, how to manage, how to accurately assess energy kind of within those boundaries. The challenge with embodied carbon is those boundaries are not clear. There's versions of this where we may just be looking at the emissions associated with a product, or maybe the building in which those products are used, or looking at a site in which the building has been built, looking upstream through the supply chain up to when those materials were initially extracted from the ground, looking all the way into the future around what the predicted end of life scenarios might be. There's all these different ways of looking at the time and space boundaries of embodied carbon that there is not consistent industry-wide practice around at this point in time, nor do we expect that there will be total consistency because you'll be looking at different boundaries to answer different questions. So part of what is really needed around the standard is to create some really clear consistency and definitions around what we're measuring within what time and spatial boundaries, what is in scope and what is out of scope. And that was one of the core values of this standard, is so that we can have some consistency, so that we can start building some regular practice around doing this work. And so we're going to continue to define embodied carbon in the context of the 1550 standard so that we can have a standardized way of bringing those definitions to bear in this particular form of residential assessment. And what's really nice about doing this in the context of the RESNET ecosystem, and why it was really valuable that this came about as a RESNET standard within an energy program, there's actually a bunch of points of value here. Again, if we're looking at carbon emissions, being able to look across the whole life cycle with operational and embodied is really valuable. But we're also leveraging the work that the RESNET organization and community has already done of looking at these various forms of energy and emission related impacts. And so in addition to that core HERS index looking at residential energy, we have the water index, which is looking at emissions associated with water and utilization of water. We also have the carbon index, which is super valuable in that it translates energy as a metric into the carbon emissions associated with that energy. So there's already some standardization and structure around how to convert energy into carbon on the operational side. And so embodied carbon as a focus of study kind of leverages that, so scaffolds on top of those other metrics to really help us fill out the full picture of what the impacts are of our built environment and how we can assess those and control those better. And so we really see the 1550 standard as sort of building upon some of the other really good standardization work that's been done within the RESNET organization. The provenance of the standard was like sort of by and for the ResNet community, and so big shout out to the Northeast Home Energy Raiders Alliance, Northeast HERS Alliance, for really like being the fire behind this initiative. I know Andy Bacino is on the call here. Shout out to Andy and the whole team at Any HERS for championing this. Their work alongside with RMI, and particularly Chris Magwood at RMI, who served as the one of the co-chairs of the 1550 committee that helped to bring the standard into creation, and then obviously working within the ResNet organization as a ResNet standard. That was the team that really sort of coalesced to bring the standard into production. And so I think and we'll talk more about this in detail as we talk about both the standard and the study. This is really by and for the rating community. And that's really unique amongst embodied carbon standards internationally, whereas a lot of those standards are really focused around, say, sustainability consultants or architects or other practitioners working on, in different scopes or fields of work. This is really for the rating community. They're already engaged in the work of energy assessment to also be able to broaden their scope and take on embodied carbon assessment and material impacts as well. That's a really exciting part of the standard. Okay, so let's get into some more formal definition here. I wanted to sort of weave that into how this is defined in the context of the standard. Again, there's lots of different ways of slicing and dicing these boundaries, but sort of zooming out, when we say embodied carbon, we really are looking at the entire life cycle of a product, or in this case of a building, that starts with the raw material extraction out of the ground or out of the forest, or where those raw materials are coming from, their transportation to a manufacturing facility, and their manufacturing into products. That whole phase, that A1 to A3 is the nerdy LCA sort of a coding for those different stages. That's also known as the material emissions or the product stage. That's really what it takes to create those products. That is the boundary that the 1550 assessment standard looks at. So we're looking at that A1 to A3 boundary. That is also the vast majority of the emissions over the full life cycle, particularly for residential scale products. So we're really capturing the majority of it. It's also we have some of the best data. We'll talk a little bit more about some of the data quality there. Suffice to say, if you were to look at A4 and A5, that's transporting those products from the manufacturing facility to a site and installing them. That's the construction stage altogether. That would be the upfront emissions or the pre-occupancy emissions, a couple of different ways of phrasing that. That's basically all the emissions before the building goes into its use phase. Then we've got a few different categories in that use stage, including that B6, that operational energy stage. That's when we're talking about the HERS index and explicitly the carbon index, which converts the energy into a carbon value, into a carbon emission value. That's looking at that B6 stage. So when you combine the RESNET standard with the HERS and carbon indices, that's what's covered in those phases of the life cycle, and that's what we those two stages really capture the vast majority of emissions across the whole life cycle. There are, of course, also emissions associated with the end of life, that C stage, that's deconstruction, demolition, more transportation, landfilling, waste disposal, so on and so forth. All together, we would call that embodied carbon. And that's where it gets confusing because embodied carbon could be used to describe the whole life cycle or a portion of the life cycle. And so we need to get a little more articulate, hence the value of the standard defining. We're looking at that product stage, that A1 to A3, raw extraction through to manufacturing. And that's a typical boundary for the residential space, and that's what the RESNET 1550 standard defines as embodied carbon.
Yeah, thanks, Jacob. I've also heard it referred to as cradle to gate. So sort of like
Yes,
creating the product and getting it up to the point where it goes out to the home. That cradle to gate
exactly.
is
That's
another
a
way.
great one. And gate would be factory gate. Cradle to grave would be through that C phase. That'd be the end of life there. And for everyone sort of cradle to cradle, that would be a circular economy where we'd be taking that cradle all the way back to the development of a new product. Beyond the scope for us, but yeah, good to normalize some of that language. So when you look at the actual methodology of how these calculations are conducted in within the 1550 standard, I'm just going to call out here. You see this GHGE. I'm just going to try and define some of these terms as we see them here. That's greenhouse gas emission equivalent. We'll sometimes see that as GWP, which is global warming potential. These I would call those like roughly equivalent without getting too lost into the weeds here of like parsing the fine details of those terms. Essentially, what we're looking at is all of the emissions released into the atmosphere, which could be dozens of different types of chemicals, all normalized into a single unit based on the impact of a molecule of carbon dioxide. So, for example, methane is like 30 times, roughly 30 times the impact of carbon dioxide over a 100-year period of time. So that would have a GHGE equivalent, a value of 30. So we're looking at all the different greenhouse gases, normalizing them to their potency of a molecule of carbon dioxide, and that's that metric that we're looking at. So when you see that GWP emission factor, CO2e is another way of expressing that same content. That's like the formal metric, carbon dioxide equivalent. So we're looking at the amount of emissions per given unit, per area or volume or mass of a certain product. We're multiplying that out by the amount of product we have. And so let's say we're looking at, we have X number of, 100 meters squared of concrete block times the emissions per square meter of that concrete block, and that gives us our material emissions. We sum up all the all the materials in the building, and that's our total building emissions as defined in the 1550 standard. Again, there's other ways of doing this math depending on what standard you're following, but this is how the 1550 standard runs those numbers. The source of that data comes from environmental product declarations. You can think of those as essentially environmental nutritional labels, if you will. It looks at a series of different environmental impact categories: ozone depletion, smog formation, and also global warming potential. So we're looking at the declaration of that global warming potential coming from these data sets that are produced either by the manufacturers themselves or their trade. Pardon me, their trade organizations. Those are the typically who is doing this reporting are the manufacturers of their representatives, and these are third party validated data sets that are aligned with international standards. So there's a lot of rigor and structure and standardization around this data that is the primary source for how these assessments are conducted in the standard. The scope of the work is, again, as we were referencing before, you could be looking at the product level, the building level, the site level. So for the 1550 standard, we're really looking at essentially the drip line in. So if you look at the drip line of any roof that is formally attached to the building and draw a vertical line down as if you're a falling drop of water, everything inside of that is roughly what we are capturing in the standard. And there's tables that get very explicit around that, including some of the exclusions that are explicitly not included. So for example, some of that site work and driveways, that's outside of the building. We're not including that. Appliances and some, fasteners, some lighting fixtures. There's some particular smaller or more detailed or product categories that don't have sufficient data to be captured at this point that are also excluded from the standard. And those are all listed out in the standard to make that that scoping really, really clear.
Yeah, thanks, Jacob. And I think some of that there were kind of two questions when making what's in and what's out. It's sort of like, is this a decision point that can actually impact the embodied carbon? Like, does it
Mhm.
matter? Every house has paint. Like, is there a big difference? And then it's also like, how difficult is it to collect? And is there a robust EPD library for that product? So that also informed those decisions. So.
Exactly.
All right. Thanks for all of that, Jacob. Uh, to continue on with the 1550 standard, it's broken into the traditional kind of ResNet parlance of, hey, there's a projected assessment and a confirmed assessment, where you can generate a projected embodied carbon number, and then through following the methodology outlined in the standard, you can generate a confirmed number. And again, this is a number that is expressed in CO2 equivalent, not sort of a indexed number like the HERS score. So this is a way, basically just a methodology to express how much embodied carbon there is in a home within that A1 to A3 range. Um, Also, there's verification aspects to the standard in terms of what data needs to be collected to substantiate your findings. And, there's not a quality assurance piece yet, but we did start to address some of that in this Massachusetts study, which we'll get into. So, think of this standard as like groundwork for a larger embodied carbon assessment to be built on top of, and all the things that we associate with a HERS rating. There's a strong foundation in terms of what are the minimum rated features, what are the kind of stages in terms of projected and confirmed, that those rules are now in place. Okay, so let's go even more narrow from the standard. Let's talk about the Massachusetts 100 home study. So Massachusetts is a unique state in terms of HERS rating. About 100% of new homes built in the state of Massachusetts receive a HERS rating. The entire energy code of the new residential construction space in the state is based around the HERS score. So there was a lot of interest from that state to, hey, can we start to work in embodied carbon into our energy code and things like that. And there were two main goals of this 100 home study. Number one was establish an embodied carbon baseline for Massachusetts. Once you know kind of the average embodied carbon, you can start to incentivize, which we'll touch on later in the presentation. The other goal was to collaborate with raters and kind of build a HERS rater workflow to capture this information. So, about 60 to 70% of the information needed to do an embodied carbon rating is already captured through a traditional HERS energy rating. So, what would it take to go from the HERS rating to a full embodied carbon rating? And basically, a workflow was built with Ekotrope and HERS raters and any HERS, a number of other, Builders for Climate Action, a number of other folks to build what would this look like. And this study was done during the code development process for 1550. So we were able to kind of inform the decisions in the standard around the experience of HERS raters doing this work in Massachusetts. Uh, Shout out a few funders of this study, National Grid, which is a utility, Massachusetts Clean Energy Center, and Eversource, which is also a utility. So big thanks to them. And then all of the folks that participated in the study, Ekotrope, AnyHERS, Stevens and Company, Builders for Climate Action, and is there one more? Yeah, NMR, who helped with the reporting on the study.
And I want to give a particular shout out to Melanie Trottier from our team.
Absolutely.
I'm representing BFCA in this webinar and was behind some of the study as well, but she really held the torch on doing a whole lot of this groundwork. So special shout out to her for that one.
Absolutely. So what was unique about this study? Well, we touched a little bit on it. It was the first embodied carbon study to include HERS raters and be built for HERS raters. It was the first North American embodied carbon study to include MEPs in its scope. And it was the first study to show a blend of the HERS index, carbon index, and embodied carbon. And it was developed with 1550. So it is really kind of laying the groundwork for further work in this space. We think of it like the HERS index is based on the 2006 IECC. We're kind of in 2006 right now for embodied carbon. We're at the beginning of what will continue to grow and expand, hopefully. So let's talk about the workflow a little bit. What did it look like for a HERS rater to do this work? Again, life cycle stages. These 100 homes had already done a HERS rating. So they had already captured the B6 and B7, or I'll say B7, which is energy, not as much B6, which was water, which was not included. But we were going to include A1 to A3 as part of this study. Fundamental difference between modeling for a HERS score and embodied carbon is the envelope. So an energy model, we're focused on the thermal envelope. Where does the conditioned space meet the semi or unconditioned space? For embodied carbon, you're looking at everything. You're looking at your garage. You're looking at your unconditioned basement. You're looking at your interior walls. All of those things contribute to the embodied carbon. So it expands the scope of what the HERS rater needs to look at. One other note I should just mention about the 100 homes. They were selected based on studies that had been done in Massachusetts to represent a typical average of the homes built in Massachusetts. 80% of them were single-family detached, where 20% were townhomes. And we also tried to average for HERS index and square footage in terms of making the averages of the 100 homes match the last year or two of construction in Massachusetts. So that also went to that baseline piece. But this scope, I think, is really important when we're talking about how HERS raters are going to collect this information. When we look at Ekotrope, and for this study, BEAM was the tool that was used for the embodied carbon assessment. There are some fields that are basically one for one. Hey, this is an Ekotrope, and we can just take it and plug it into BEAM and we're good to go. There are things that are partially captured, and then there are things that are not captured. So just a few examples. Exterior walls. In Ekotrope, you're already labeling out what every material of the assembly is. That makes a pretty clean transition to embodied carbon. Whereas something like a slab, in Ekotrope, you put the area and the perimeter of the slab. You don't put the slab thickness. So that's something that needs to be added through this uh, embodied carbon workflow. And then there's other things like, you know, slab footers that are just not part of an energy model, but are really impactful for embodied carbon. So part of this study was just understanding what those gaps are. Uh, this is kind of a workflow document, I would say. On the left, we started with the 100 homes. Basically, they were approved by the team that were administering the study, and each project had to have corresponding drawings as well as an energy model. So all of these homes had previously been HERS rated. So they were a bit of like Frankenstein projects. Like raters were bringing them back from the dead to do an embodied carbon model. The home was already constructed. So some of the workflow takeaways was like, it's really difficult to like, do this on a home that's already been rated. It would be much easier to do it kind of in the traditional HERS rater workflow from, hey, we're reviewing plans and then we see it as it's being built and we can ask more questions of the builder. So these are just some of the limitations of this study. The HERS rater took those two things, the project model and Ekotrope and the drawings, and then we built a integration worksheet which called out some of those gaps of, hey, we have your slab area, but we don't have the slab thickness. So like it populated the area, but you had to enter in the thickness, things like that. And then it put it in a format that was easy to port over to Beam for the final embodied carbon model. And that integration sheet and the Beam model were 100% QA'd by the study team, which was a very large undertaking. So basically, this was a bit of a hack. I'll kind of say hack together workflow for the purposes of this 100 home study. But we learned a lot, and I think there's a lot of takeaways to build off of in terms of how HERS raters will actually use this in the future. To go just a layer deeper, on the left, you might recognize these screenshots from Ekotrope. This is the wall assembly calculator. So let's say for whatever reason you had 2,000 square feet of above grade walls. 1,600 of that square feet used fiberglass bat and 400 square feet used mineral wool bat. When you go into Beam, you're only looking at the above grade walls out of basically 100% of that wall. So just kind of the expression of how these wall assemblies show up in Ekotrope and show up in Beam are just slightly different. And that's part of what the training and integration sheet look to solve for. What you would do is in this instance, you would pull it over to the integration sheet. It would break down, hey, you have 2,000 square feet of cladding, membrane sheathing, but cavity insulation is broken out 80-20. And this just made it easy to take it over into Beam. In terms of MEPs, I'm actually going to hand it back over to Jacob here.
So there's a lot of work in bringing MEPs, mechanical, electrical, and plumbing equipment into the purview of the study. This is actually included within the standard and was not initially included in the study, but then a shout out to, I think it was Eversource in particular, who helped to fund expanding the scope of the study to include MEPs so that it was as closely aligned with the standard as possible. MEPs are a little bit special, separate, relative to the other materials in the home within the scope of the standard, largely because of data availability. So this is an area where there is just not the same depth of EPD data coverage as we have, say, in insulation or finishes or structure. So there is a fair amount of additional research work that we did to validate for the standard a robust set of default values that could go into the standard and make sure that these really critical categories of the building were being captured. It's not to the same resolution that we'd like to say product A versus product B, which one should we choose? We're looking forward to having more data and sufficient data to get to that granularity of choice. But as we'll see when we get to the results section, this is a really big category, and it was really important to make sure it was captured in some regard. So that was included in the 100 Homes study. And as a portion of the standard, what again is really exciting about being able to develop this in a standard that is targeted for raters is that we're establishing the units of measure and the inputs for the MEP divisions to align as closely as possible with how raters are already collecting that information. So I think the next slide gets us a little more detail. Yeah, great. So when we're looking, for example, at heating and cooling equipment, that's already being captured in energy rating, and we are already looking at what the capacity of that equipment is. Now, it's not a linear line between capacity and embodied emissions, but there is an association with the embodied emissions and the scale of the equipment. So we're able to use that as a base metric to sort of get a good default value that's aligned with what's already being captured by the rater. Another great example of that, well, if you're looking at something like fans and pumps, those are selected by the per unit in an energy assessment, and so we're using that same metric in embodied carbon. What was really great to learn is that in a HERS rating, we're already looking at the lineal footage of ductwork that's being distributed, and so we're able to look at essentially do some conversion calculations and some basic defaults around what is the emissions per given square foot of ductwork, so that there doesn't need to be redundancy in the data capture on behalf of the rater. We can take the data that's already being captured and use that to get reasonable coverage of default values for some of the those types of equipment.
Yeah, that's a great point, Jacob. And I remember there was like talk of, well, maybe we want to use, length of the refrigerant line for heat pumps or things like that. And we were able to say, hey, actually, that's like could be a lot of added scope for the rater. Let's just use capacity. So,
Exactly.
I think that was one of the benefits of doing this study in tandem with the standard development. So, okay.
Exactly.
We're going
Exactly.
to go into some of the embodied carbon results here from the study. So I'll hand it back to you, Jacob.
All right. So what we're looking at here is we call it so the total emissions here. This is again we're looking at metric tons of CO2e, so that's all greenhouse gas emissions normalized to the impact of carbon dioxide. And this is looking at the total numbers. And so you saw earlier in that very first slide, we were looking at 55.5 tons of emission as a given value here. And this is where it's coming from. That was the average looking across these different types of buildings. Worth noting that, yes, we're seeing one of the larger categories being a two-story single detached building, given the sort of form factor of that building. There's some logic there that kind of makes sense. It's also interesting to see some of the error bands associated with some of these given categories. We see some like really high outliers and some really low numbers in here as well. And we'll talk a little bit more about that too. But just a couple of patterns to pick up from in some of what we're seeing in our totals. And again, that 55 and a half tons of emission per typical home averaged across these different home types for 100 homes in the study.
Yeah, and I mean, I think the fact that homes ranged everywhere from 144 tons to 18 tons, I mean, that's encouraging also because that means there's a lot of slack in the system. Like this is just a baseline. And it should be fairly easy to, what gets measured gets managed. So.
Exactly. And we'll talk more about that pattern when we look at some blended results here in a moment. What's interesting to see when we look at that, not just as the total emissions, but the emissions per square meter of conditioned floor area, the pattern starts to change a little bit. And now we're actually seeing the two-story buildings being among the lower categories. And then townhouses are sort of jumping off the page a little bit there. And so this gets to a really interesting part of the conversation, which is, well, what are our units of measure and how are we comparing different types of buildings together? And what are we using to do these assessments? In the 1550 standard, I'm going a bit by memory here, but I believe there's 4 different required metrics per the total emissions, the per total floor area, per conditioned floor area, and per occupancy. And those are all required to be reported out. It doesn't take any additional effort on behalf of the rater to run those numbers. I'd say that's as one of the developers of the Beam tool, that's our responsibility to provide those metrics for you. It doesn't take different inputs on behalf of the rater per se. But what it does mean is that we now have different metrics that we can use to answer different questions. The same way that we're looking at energy, we may be looking at annual energy consumption when we're trying to size our solar system, but we're looking at peak load energy consumption when we're trying to size our mechanical system. We need different metrics to make different decisions around the building. And so the standards is that it is anticipating, hey, embodied carbon is actually a big topic. There's a lot of different ways of looking at this, and we may need to make different decisions or develop different strategies based on different ways of looking at this course of measurement. And so there's a series of different metrics that we're using. In this case, we're looking at per conditioned floor area, and again, reveal some different patterns and some different windows into impact. Now, as we look across these different types of buildings, the townhouses jump out a little bit more. And so comparing a townhouse to a two-story building, becomes is challenging and becomes it looks differently when we're looking on a per area basis as opposed to a total emissions basis. And so when we're looking again, kind of across, not just within the 100 homes study, but comparing that to other benchmark assessments that have been done, Builders for Climate Action has done a lot of benchmark assessment in municipalities across North America, pulling from a few different ones here in Vancouver, in Toronto, in Nelson, in British Columbia. The Toronto study was particularly large, 500 different buildings, over 500 different buildings were looked at in that study. And what we're seeing is a very consistent pattern of the average, as well as the high and low kind of whisker bars around the 80-20 split on those outputs. And so that gives us a lot of confidence that the reporting that we're seeing from this study is aligning really well with other benchmarking studies, giving us an increased confidence in the value of these outputs as being well representative of this type of construction. And maybe one of the most useful things to learn from all of this is, like, where's the carbon? Like, where are the areas in the building that these emissions are really showing up so that we know where to focus our energy? Because the last thing we want to do is burn up a whole lot of financial and attention and time resources trying to solve really small problems and missing really big issues. And so one of the valuable things we saw is really where the emissions are showing up. For those of you that have seen me present on some of this content before, perhaps in some of the benchmarking studies, this will look familiar with a really notable change. In this one, we actually have MEP in the study, which is super exciting. This is not something we've, as Patrick mentioned earlier, it's kind of a new feature of this study is to bring MEP into the scope of evaluation. And I'm really glad we did, because it is the second largest plume of emissions after concrete. So again, we're really excited to have an increasingly granular and robust data set to be able to drill in more detailed, okay, what within mechanical is driving that, and how do these different heat pumps compare to each other? We're going to have more and more information around that, but suffice to say, it's a really big point of concern in terms of where we need to focus our emission reduction. And it's also the area where we see overlap between the equipment that is creating embodied emissions, that is also some of the same equipment that is consuming a lot of energy and contributing to the operational emissions. So that gives us some great opportunities to identify some shared strategies where a single move or a single point of focus around a piece of equipment can reduce emissions kind of across the whole life cycle of that product category. And that's a big win. That's exactly where we're going to be focusing our attention. So concrete, MEP, insulation, another pattern we can identify is when we're looking at smaller types of buildings relative to, say, institutional buildings or large, very large buildings, they tend to be dominated by the materials that make up the skin and the enclosure, because the surface to floor area ratios are pretty high on smaller buildings. So we're seeing things like insulation and cladding jump out. And since most of these buildings are framed with light wood frame construction, the framing numbers are actually quite low. That's one of the lowest carbon ways that we could build structure, is using small pieces of wood. And that's the dominant structural kind of profile of a lot of these buildings. And so that's some of what's behind this pattern that we're seeing here.
Yeah. Great stuff, Jacob. The one thing I'd add is, this, along with all the studies on this slide, are done in colder climates, where, a lot of homes tend to have basements. So I'd be really interested to see one of these studies done in a climate zone 2 or a climate zone 3, where, it's more slab on grade or things like that, and how these numbers might shift there. But that's for another day. All right, let's blend. So all these homes also had a HERS rating, which is very cool because now we can say, well, does operational and embodied, do they correlate? Do they not? Like, how do they interact? Also, I just want to remind everybody, we do have a Q&A feature live here, so feel free to drop any questions you have there. It might be hidden, but we'll keep rolling. Uh, what about operational emissions? So this is that same breakdown of the 100 homes, but this is just looking at operational emissions and fuel type. So shocking, but all electric homes have much lower emissions than mixed fuel or fossil fuel homes. So the electrification is still a really big factor in terms of emission reduction, in terms of operational emissions. This is also, again, done in Massachusetts, which uses the Massachusetts grid factors in the carbon index. So, these results could change depending on the location in the US. Um, if you look at the HERS index of the 100 homes, it broke down about into a third of the homes were between 39 and 48, a third of the homes were between 49 and 51, and a third of the homes were between 52 and 60. When you look at the embodied carbon emissions of those three segments, it comes out about the same. And so what we can say from this is that the HERS index is not a predictor of the embodied carbon. They are two separate metrics. They can interact in some ways, but they're basically disconnected. Doing a low embodied carbon home does not mean it's an energy efficient home. Building an efficient home does not mean it's low embodied carbon. It's a different decision tree. But the decisions are made by a lot of the same people. So it's great that they're kind of brought together here.
And the thing I would suggest there is there was just a question about insulation in the Q&A, and that's one of the product categories that gets the most most attention, as well it should. I've seen a lot of conversations around, oh, we have to compromise or trade off between the operational or the embodied value, particularly as it relates to insulation. And I think the take home here is that no, no, no. There's no trade-off to be had. You can have, as Patrick was saying, you can have really good or really bad embodied or operational values that are not related to each other. And this is, again, looking at buildings that already existed. So we're seeing some like really low emission outcomes in both the embodied kind of profile, without necessarily that being like a formal goal of those builders. It just shows there's a big range that can be achieved regardless of the performance of your buildings. That gives us the opportunity to design to solve for both problems. And those are some of the best strategies we can lean into.
Yeah, and I think that's also part of why it's great that there's a ResNet standard here, because HERS raters influence these decisions. So they influence the energy choices of the builder. We're soon we'll also be able to influence the material carbon emissions, which we'll get into a little bit later. Okay, so what did raters think? So there were, I think, about 15 HERS, 10 to 15 HERS raters that were part of this study. They all were required to do at least 5 homes. And how big a pain was this, basically? That's what we asked them. So what they said was their first assessment on average took about 3.5 hours, soup to nuts, doing a new takeoff from the plans, putting it through the integration sheet, putting it through Beam. By their fifth or sixth model, it was taking 45 minutes less. We were down to less than 3 hours. These numbers are scary from an operational aspect, but again, I'll say these were like Frankenstein homes. A lot of times, the builder, they've moved on. They aren't answering any questions about this home. Also, this was brand new. There wasn't a ResNet standard at this time. So this is just kind of first pass. And I think there's a lot of room for improvement here. And if this becomes built into the takeoff process, and Ekotrope, like we're starting to do more and more product listings, and Beam is available as well for a lot of these decisions. So I think there's a big role for software in this space as well.
The one really small add I'll make to that is speaking from the Beam team, we are actively developing Beam as a tool specifically in response to this so that we can ensure that we're taking that number down as low as absolutely possible and reducing as much friction for the rater as we possibly can to be able to get to a good outcome from the tool results. So that this was a huge learning for us as a tool provider in where the friction lies and how to reduce it and setting some goals around that.
Yeah, absolutely. Uh, Go for it.
Yeah, and so what's really, really exciting about this study and how this study nests into the sort of the landscape that we're in right now is that we're really seeing both not just the opportunity, but the realization of some real market transformation here by having such a sort of multidisciplinary or sort of a multifaceted approach to this work. It's not just looking at this from like, all right, how do we make this number smaller for this product? We're really looking at this, the relationship of how we're developing standards that are responsive to the industry and matched well to the industry's current practices, and not just creating a standard and expecting the industry to, figure out how to get there. And we're, as I just mentioned, around the development of the Beam tool, I sort of mentioned a number of different ways in which we're also trying to, now that we know what it's like to try to implement this out, even at a small scale of just 100 homes, how do we continue to reduce that friction so this can really be deployed at full scale across the industry and make this not a burdensome practice, but something that actually really brings real value to the raters, to the builders, and to the market, and design for that outcome. And then what needs to happen all the way along to make sure that everyone can align towards those shared goals. And as opposed to, again, starting from this, top-down regulatory approach, but rather having this be developed from within industry, and having industry guide the development of not just the standards and the technology, but the best practices around how to conduct these assessment activities. We're already seeing in real time the success of how we're able to have work that can be made actionable and bring value to the market in real time. And that's maybe the most exciting part about this. For those of us that have been in the energy space for decades, that has not necessarily been the case of how energy standards and regulations have played out. And we see a real opportunity here in looking at materials to learn from those experiences and figuring out how to have a coordinated work at transforming the market so that this is actually way more value than burden to the industry.
Absolutely. So the question out there, now what? How can this be applied? What was the point? Like what happens now? So we're going to talk a little bit about a few instances where this is actually happening and a few things you can do right now. Also, there was a question that I just also want to mention. There were no inspections done on these homes. These homes had been HERS rated sometimes up to a year previously, and people are living in them. So there was no inspection scope here. Jacob, do you know, if I remember correctly, there's very little inspection scope in the standard. It is primarily a paperwork and takeoff and plan review exercise. Um, there is some level of verification, but there's no diagnostic tests. There's nothing like that.
Correct.
It's primarily a paperwork and documentation process.
Yes, that's exactly right. And it gives the opportunity to make some decisions and optimize for those that are motivated to do so, but doesn't require that. And maybe the other thing to mention is I don't know if this was mentioned before, but while we're sort of talking about that scope of the standard, it is just making assessments. It's not an index. It's not a rating. It's not evaluating good or bad the way that the HERS index is. And that's important to name right now. It's too early for that. We're just doing some of our initial benchmarking studies right now. And so while that is expected to follow at some point, as we see these really large bars of what best and worst can be, we see an opportunity to shrink, bring that top bar down. But right now, it's just assessment of what the impacts are. And to your point, Patrick, it's not actually conducting any testing or diagnostics. It's just documenting what the impacts are.
Yeah, absolutely. Okay, so now what? So we're going to talk about Massachusetts again here. So the Massachusetts Energy Code has, again, it's all based around the HERS index. So this is one very specific example of where embodied carbon is being implemented in the market today. You can see if you are building a mixed fuel building currently, you have to have a HERS of 42 to meet code. That's tough. That's hard. Um, and so Massachusetts has given some ways to get around that a little bit. If you do a, all electric building, you all of a sudden only need to meet 45. You get 3 points of grace. They've also implemented these embodied carbon credits, which we'll show in a moment, which gives another 3 points. So if you build your home as all electric and use one of the embodied carbon credits, all of a sudden you only have to hit a 48, which is real money savings for a production builder. And these have been fairly popular pathways to take in Massachusetts. Um, I'm not saying this is the approach that every jurisdiction will take or is even a good or bad one. This is just one, really the first large scale implementation of this in the US at this point is basically trading off 3 HERS points for embodied carbon. Um, the two credits that are available in Massachusetts are the insulation embodied carbon credit, which is basically sort of think of it like a total UA calculation. If the overall average of your insulation has negative embodied carbon, you get 3 points of grace. How would you have a negative embodied carbon? You would use a recycled material like cellulose or something like that. There's a lot of examples. Uh, the other option is low global warming potential concrete mix. That basically over 90% of your concrete has to be below. There's a reference table that lists how much uh, GWP your concrete has to be. So it's basically in use concrete that's a little bit less carbon intensive on 90% of your concrete volume, and you get 3 points of leniency. And this concrete one has been pretty popular in Massachusetts because this enables product manufacturers to say, oh, I can market this product in Massachusetts because there's a real market driver behind it. So this is just one very specific example. The other one that we saw, concrete is 40% of the emissions in this study. So I think Jacob speak to this one a little bit.
Yeah, absolutely. Concrete's a great example of where, again, it's the number one sort of material category where we're finding these high GWP emissions. And we see that really consistently across all of our studies. So obviously that's a great place to target in terms of where we want to see our reductions happen. It's a great it's a great sort of case study for all of the different ways that one could conduct emission reduction across a given product category. And I just want to call out, there was a question in the chat about steel. Is steel included? And I mean, just see, I think Matt Wright had a question around you're working custom homes. There's more and more steel being used in these homes. I'm going to say these same approaches for steel reduction really apply to concrete. So I just want to kind of link those together. In this case, there's a lot more concrete, but when we're looking at these structural material reductions, the number one best thing you can do that saves money as well as saving emissions is reducing the required amount of massing for concrete. That can be done with optimizing your building design. If you have a building with 18 corners, maybe you can work to reduce that down to 12 or even 8 corners. And that's going to dramatically reduce cost and time, complexity, risk, durability impacts, as well as the embodied carbon of the complexity of that footprint. You can tune in the strength. We see in the residential space dramatic amounts of over-engineering in concrete placement, largely because there isn't engineering support for tuning in the required strength for a given concrete application. That's another way you can both save cost and save emissions at the same time. Some different formulations that you can use, bringing different additives. People may have heard of like fly ash or slag being used. There's a host or higher lime content cements that can give you the same performance characteristics without necessarily adding cost, depending on your market, while also dramatically reducing your emissions and doesn't require complex re-engineering or any changes in the workflow. And then we can get even more optimized or maybe a little more cutting edge using some emerging technologies of different additives like biochar, or there's now additives made out of, say, ground recycled glass that can reduce the amount of Portland cement going into the mix, or even non-Portland based material solutions like Sublime or Prometheus materials Prometheus is actually using a bio-based binder for their concrete and precasting blocks. And so those aren't going to be available in every market. They may not be at cost parity, but as a way of really optimizing if you're trying to lean into reduction. So all that to say, both in, from design to procurement and from legacy to like cutting edge innovative solutions and everywhere in between, there's a pastiche of different solutions that you can bring to bear depending on, who you are in the process and the nature of that project and what some of the, project requirements are. But there is something there for everyone, including folks that are also looking to reduce cost. uh, it's a very common thought that in order to have a lower carbon building, the cost has to go up. And the same way that operational and embodied carbon metrics do not predict each other, cost and emissions do not predict each other. As we saw, we can have some sort of market rate buildings that are incredibly low carbon, and we see a whole lot of solutions like reducing your massing that are saving both cost and emissions with the same move. And those are the ones we want to try to identify and uplift.
Awesome. Just to call out a few other opportunities, there's builders with sustainability goals tied to emissions reductions. We did see a few large national builders mention embodied carbon in their annual sustainability reports. So that's an area that, hey, HERS raters already help them with their sustainability reporting. This is an added thing you can offer. There's utility companies that certain states, have utilities uh, set carbon reduction goals. They can incentivize around embodied carbon potentially. And then obviously, Massachusetts and states like it, like we've heard California is discussing rolling out embodied carbon as a requirement of a rating and things like that. And then also green building programs. So uh, I would say, again, it's early days. It's 2006 for the HERS rating. Why would somebody do this? Right now, either you're in Massachusetts or you just are a carbon nerd and you really care about this stuff. But these conversations are going to continue to happen, and product manufacturers are going to continue to try to meet this growing market. And HERS raters have a very influential role to play here, where if places are seeing diminishing returns on their energy code, they might turn to something like carbon code or something like that. Again, this is forecasting for the future, but HERS raters are an influential stakeholder in this process and are going to be at the table for some of these discussions. So we wanted to kind of just provide education for here's what we know about this, and let's work on it together. And I think this is our last kind of wrap up slide, and then we'll have some time for questions. But some bottom line takeaways: you must consider operational and embodied emissions together to reach decarbonization goals. If you want to build a low carbon building, you got to look at both. Looking at one is not enough to make that claim with validity at this point. And then HERS raters, they can make this happen through measurement and recommendations. They're very uniquely positioned to be the people that implement and make this happen throughout the country. Or do you want to take these, Jacob?
Yeah, absolutely. We're really seeing the rollout of the standard as well as the sort of forthcoming tooling infrastructure that at least we're working on in BFCA, and we expect to see there's others in the field as well doing this work. There's gonna be more technological solutions that are only going to make this lower friction and more value add. And so again, we're in early days, but the changes are moving rapidly, and the rate of change is moving a lot faster than we've seen in the past, particularly in the technological realm, to make these processes more valuable and more effective and more efficient. And if you're just wanting to take like an immediate next step on a next project level and want to like ground it down into immediate practice, focus on the things that are really driving those emissions and just take it one step there. Start with concrete. Find one of those techniques to bring those emissions down a little bit. Look at a simple one-to-one swap of an insulation from something that's super high emission to something that's just even not as bad, or may even be a bio-based insulation that actually stores some carbon and has a negative emission value. Looking at MEP and right sizing your MEP has both upfront cost of benefits, energy efficiency benefits, equipment longevity benefits, and reducing the embodied emissions. So looking at some of those really focused key strategies that may already be within easy grasp would be a great place to start if these bigger concepts are not quite within your immediate grasp.
All right. Thank you, everybody, for sticking to the end. I think we have close to the same amount of people we had at the very beginning, so that's great to see. We'll stick around for a few questions, but you know, this will also be posted on the Ekotrope YouTube page, and we'll share that around as well. So thank you all for attending. Guess a couple questions. Yeah, I think we addressed Matt's question about steel, that steel is a material available in embodied carbon assessment, and there are EPDs for it, so it can be assessed. Um,
Absolutely.
there weren't a lot in this study, if any. I don't know, but it can be addressed. Uh, I'll be just
Yeah, the describing the market drivers and why would a rater do this? I think we covered that, but I just want to like name those really clearly, just so it's right there on the table. It's a way of providing additional value to, if you're a rater, why would you do this? To help support your builder be able to reach a market that's interested in sustainability metrics or climate reduction metrics. Again, if you're looking at decarbonization only from the level of energy, you're definitely not hitting the whole picture and aren't really hitting some of those core carbon reduction goals. And that's a way to bring more value to access that market. For more corporate builders or folks that have ESG reporting that requires emission reporting, this is actually a really important metric to be able to validate positive ESG reporting for those of you working in that market. Recognizing that there are in some good strategies can reduce cost as well as emissions. It becomes a mechanism of looking at material efficiency. And even if it's not the carbon number per se that you're chasing, but a mechanism of being able to evaluate how can we more cost effectively reduce materials within this building, this gives you a really good, clear workflow of being able to do that assessment. And then certainly if you have personal project goals or goals within your own project within the firm that's trying to make those reductions, there's a great opportunity to do that by just starting to make those assessments right at the gate. Of course, the regulatory environment in Massachusetts gives a lot of incentive, but we're seeing absolutely both sort of regulatory and incentive programs in largely in municipalities as well as in some states and provinces across Canada and the United States. So we're seeing more and more and more of those, and we'll only see more as we move forward and hitting towards some of these state and municipal climate reduction goals. So being prepared and ready to respond to those as they continue to develop is a really valuable strategy as a practitioner. I may be missing a couple of other ones, but those are some of the obvious ones that jump right off at the gate for you can be finding good reasons to start incorporating this into your practice right now.
Yeah, it's a tool in your radar tool belt. It's, if there's interest, you can do it. Okay, question from Andy. Has Ekotrope or Beam seen any emerging state or municipal codes leveraging 1550? What is the market? Can rating companies expect to have incentives attached to low embodied carbon to seed the market? I would say we, kind of just talked about this, but there's definitely a lot of talk of different places potentially putting this in their code or things like that. I would say I don't think there's been much development beyond Massachusetts that's out and live at this point. But it's continuing and the conversation is spreading. So I would say not really at today, but this is going to continue to evolve over the coming years.
Yeah, we can just add a few little bit of forecasting bits and bobs there. Again, looking beyond like particular municipalities, which are definitely moving in this space. What we're seeing is there is already a lot of policy in place around like public works projects or public funded projects and commercial projects. There is actually a broad landscape of policy in those parts of our industry right now that are very much designed as precursors to the residential sector. So this is very much looking like a case of when, not if, that landscape of policies are going to be expanded to include the residential space. And we're seeing that both in Canada and in the US in active planning documentation that's out there. I'm not going to call out particular states or municipalities like right now. That would be a little bit more than we have time for. But that pattern is very much present, and we can expect it's not like, well, maybe they'll get around to it. No, these are policies that exist right now for public procurement of materials, for publicly funded buildings, for commercial sector buildings. We're seeing that repeatedly, with targets of that being the first phases that will then be expanded to capture the residential space as well.
Absolutely. Thanks, Jacob.
Mhm.
Yeah, question on the embodied carbon credit. Does the builder need to use low embodied carbon materials across the whole project, or can it be earned by just applying it to one material category, like concrete alone? Yeah, so it's category specific. There are two ways to do it. You can either use low carbon insulation or low carbon concrete. You don't need to do both. You don't need to do other things. You just need to do one of those things. So, I would expect in the future there might be more options, or you might have to do a combination of things. But right now, it's one of those two, and then you get 3 points in Massachusetts.
And those point to two different strategies if you're not necessarily looking for a credit, but just like, all right, how do I start with this? Like, how do I get my way into this? Again, it can be really easy to just look at one of the big drivers and just try to reduce that driver. That's going to be really good and way better than doing nothing. And if you're looking at this or more like I'm looking across my whole building, you may find, for example, dang, I really need steel to be able to make this architectural design work, or because that's a really critical part of my structural solution. I know that's going to be a really big hit, my foundation division. Can I then look and see if there's other places in my building where I can make some other decisions to help turn down the emission intensity, say in my finishes or in my insulation? And so there's like two different ways looking at whether it's on a per product basis or looking more holistically that you can make just different decisions and execute different strategies to help manage carbon emissions across the building, even if your goal isn't to like be zero carbon. That doesn't have to be the goal for this to have value and be worth the exercise.
Yep. Is Ekotrope ready to use to gather embodied carbon information with the beam integration? I would say if you reach out to me, I'm Patrick at Ekotrope, we can refer you to the folks who are in charge of that integration sheet. I would say, I think there will be more to come on this front in the future. There's definitely a lot of opportunity for um, software to take on some of this work. I would say uh, feel free to reach out and we connect you with the folks who are in charge of that integration. It's the Any Hers group, but uh, today you cannot do embodied carbon in Ecotrope. We're not set up for that. David asked, were the beam carbon results compared to the carbon index value in Ecotrope? Were they similar or different? Great question, David. That's a bit of what this. Is it this one? Uh, yeah, this one. If you look here, the light green part of this column is the operational emissions, and the dark green is the embodied emissions. So the light green is the emissions based on the carbon index, basically the fuel usage times the emissions factors based on a 25-year grid horizon. And then the green is the number that came through the Ecotrope beam integration workflow. So that's, I guess, what we're touching on in this slide is that, you know, the uh, the carbon index is, tied a bit to the carbon index is more tied to the fuel usage here. Like this is the carbon index numbers of emissions. It's not necessarily correlated to the embodied emissions. Um,
And there's a maybe one little note there. There's a bit of a I see a kind of common pattern around trying to compare or trade off the embodied versus the operational like buckets as if like you have to pull from one to achieve the other, especially see that in insulation. And I guess what I want to like reinform in that response there is that they're not really like directly comparable where you look at like X number of units of embodied and X number of units of operational and see how they like stack against each other. I think the way that bar graph is designed is actually really useful. It's like you add them together to see what your total is, and you can optimize it kind of within both of them. Now, it's not to say in certain cases, if you're, using more insulation to reduce your emissions, there may be, as your operational emissions, there may be an impact on the embodied, but that doesn't mean that one will then go up and the other will go down. It depends on your material selection. It depends on your design. There's a lot more complexity there. And so just really want to reinforce that these are happening at different time scales, and there's different triggers in the building design as well as in procurement that cross over these categories, but they do not predict each other. And I would like encourage not to compare them against each other as if there's a trade-off decision to make there. I think that's not going to lead to the best outcomes and the best strategies.
Yeah, absolutely. Okay. Do you just want to thanks for commenting, Jacob. Uh, he's a rater in Massachusetts and mentions they have a good amount of clients utilizing the credits through concrete and insulation. And Ekotrope, we're working on updates to the HERS certificate to make it easier for building officials to read. Um, is there any reports available to download currently that simplifies the credit use in conjunction with the HERS cert? Um, there is not at this point. If you are having to write letters, feel free to reach out to support@ecotrope.com and we can likely help with a letter from our side, which can hopefully help uh, limit you needing to write those letters. But we are working on revamping the HERS certificate in Massachusetts to better capture this information and make it clearer to code officials. And then I think our last, or we maybe have two questions left.
Mhm.
How are nature-based material manufacturers scaling to fill the low carbon material pipeline locally, regionally? Jacob, do you mind taking this
Yeah, sure. I can talk to that for sure. So yeah, nature-based material solutions are often including bio-based materials, can also be looking at other waste stream materials that may be more mineral in content. And I would say this is a super exciting space. This is the sort of thing that if you're not yet familiar with that part of our industry, as soon as you start looking for it, you're going to see it everywhere. This is really becoming a very like rapidly growing part of our industry as there's more interest in materials, not just in their climate impact, but a relationship to health and indoor air quality and occupant health risk exposure, aesthetics, supply chain and land use impacts, regional economies and economic development considerations. So we're seeing a whole lot of different value propositions leveraged around using these nature-based solutions. And so Andy answered directly in like, how is that showing up at kind of at what scale? I'd say yes, locally, regionally, and nationally. And I think we're seeing these solutions sort of emerging in a variety of different responses based largely on like where your hand on the lever is as a manufacturer to be able to sort of meet the demand of the interest. And I'll just give like a couple of different examples of those scales just to give some point of reference. So on like the smaller scale, we're seeing a lot of folks working with say like agricultural residues like straw or novel agricultural products like hemp as manufactured products entering into the market. Those tend to be a little bit smaller, more local or regionally based in their scale, but are like rapidly maturing and scaling up quite quickly, coming from a smaller scale of production. Then we see some that are maybe more mid scale. Timber HP is a great example of a wood-based insulation product, actually a series of products, loose, bat, and board, that are using wood residues as their primary feedstock. Great example of a nature-based solution that they're not distributing at a much broader scale and are poised to move sort of closer towards national distribution as they scale up in their manufacturing and distribution scale. We're seeing jumping all the way up. There's a bunch of, I could name some legacy materials like cellulose is a great example of that, using recycled paper products and now cardboard products coming out of the waste stream and turning that into a high value insulation material. We've been working with that as an industry for generations, and now sort of recognizing some of the value that may not have been quite as apparent in earlier days of its utilization. And maybe some examples of like the broadest scales, we're seeing some major multinational chemical manufacturers creating bio-based foam products using methane reclamation off of landfills as a feedstock for their sort of broad scale production distribution of their products. And so we're really seeing it at all scales, again, depending on what value is being offered to the market and kind of who's entering the market. So keep your eyes out there for sure.
Absolutely. And then I think last question, which as the MEP expert here, I'll defer to you as well. Can
Sure
you
thing.
speak to the embodied carbon difference between a heat pump and furnace?
Yeah, I will encourage you to get detailed on that. Worth actually looking at the 1550 standard because the default tables for MEP in there break apart gas furnace or boiler, a split system, split heat pump system, a ducted heat pump system, and kind of give some different numbers there. I will be perfectly honest. I would want to re-reference that table to name what the difference is. There are some differences between those equipments, but they're not enormous. It's not like one is hugely larger than another. They're within a relatively tight band, but there is some difference between those, largely informed by the equipment consumption or the material consumption going into providing those different pieces of equipment. And so there is some relationship to the scale of the equipment as well. And again, I would hate to speculate and throw out this is better than that without actually looking at those numbers again more clearly. The one thing I will say that's maybe a little more relevant in terms of like why one might choose one versus another. Within the numbers of the MEP emissions that are in the 1550 standard, refrigerant emissions are not included. And refrigerants are where we really tend to see big spikes in emissions because the refrigerants themselves have a typically pretty high global warming potential. Not all refrigerants, but the ones we typically find in our heat pump equipment and refrigerant-based heating and cooling equipment, rely on refrigerants. And the more refrigerant there is within the system, and the more complex the system, like a VRF system compared to like a monoblock system, we're going to see more potential for leakage. And it's the leakage of that emission of that refrigerant that can really create spikes in the total emissions that can really be orders of magnitude greater than the equipment itself. And so that's not captured in the standard right now. There is in the standard optional provisions for calculating refrigerant-based emissions, and there are some formulas and methodologies for how to do those calculations. What gets complicated is that so a lot of people that are worried about emissions related to heat pumps are worried about the refrigerants, as they should be. And so that should point towards wanting to manage refrigerant installations well and making sure that like leakage is reduced and those designs, the installation is done well. Also, if you're reducing the amount of charge needed to provide heating and cooling service, you're reducing your upfront costs, you're increasing your energy efficiency, and you're also reducing these plumes of emissions from the refrigerant leakage as well. So there's again like a stacked win there. The thing to say is that that should not disincentivize anyone from using heat pumps because the emissions that come from natural gas leakage across natural gas infrastructure is enormous, every bit as much of a consideration as refrigerant leakage. That's just more at infrastructural scale than what we could expect to manage at the building scale. So there's this really big scale jump. And again, if we're trying to compare a heat pump system where all of that refrigerant is within the drip line compared to a natural gas furnace, where a lot of the impact and the emissions that could be associated with that consumption are upstream through some infrastructure and piping that's off-site and outside of the standard, it gets really hard to compare those directly. And so that's why that's one reason why refrigerant was pulled out of the scope of 1550 as a required measurement, but is still included as an optional measurement with some associated methodology of how you'd evaluate that. So that's part of the embodied carbon difference between those systems. Yes, there are some differences in the equipment itself. The bigger differences really tend to be refrigerant leakage, the fuel, so the fuel input leakage for natural gas, and then of course that needs to be considered in looking at what the operational emissions are as well. And it'd be hard pressed to make an argument from a refrigerant management standpoint to go to a natural gas system where you're then going to see really big emission spikes in the carbon index, and reinforces that point that Patrick was making earlier, that you need to look at the whole picture to make good decisions. That's why looking at only one or the other, you're not going to quite get enough information to really make good holistic decisions.
Awesome. Thank you, Jacob. I think that's
Thank you,
all of
Patrick.
our questions today. But again, this will be posted on our YouTube page, and we hopefully won't be the last webinar we do on embodied carbon. We'll keep going. So appreciate everyone for taking the time today. Thank you, Jacob, for co-hosting today, and we'll see you at the next one, everybody. Thanks so much.
Thanks, everyone. Thanks, Patrick, for having me. Have a great rest of your day.
Yeah.